So we came out of the stealth, and we'll be happy to tell you what we are doing. So what is ChainOpera? ChainOpera, at high level, our goal. Let me see. It doesn't update to that. Give me 1 second. I think we are not connected to the right screen. I think you're connected to just the background or something. It's not me. All right, it's working now. So what is ChainOpera? Maybe at high level, our goal is creating a collaborative AI economy for everybody to participate, right? So that's a very general goal. The goal is we are going to build the AI, but we want to do it in a way that everybody can participate in this AI economy. So what does it mean? Maybe here is one way you can think about this, right? So think about the players in the AI. You can break it to two sides. Left side is going to be the one that provide the supply, right? So on the left, for example, you have DP projects. They provide compute for training models, serving the models. Think about them, maybe Render, IONET, Akash, various projects. Then the second community is the data projects. These are the communities. For example, you want to monetize your data towards training the best AI. Maybe an example of it, you can think about Sahara AI, right? They want to be a data community, better data, better models. Then another community on the supply is going to be verifiers, contribution assessors. These are the ones that they prove that you have been doing AI. Think about them, maybe ZKML communities, ZK proof, etc. So that's the left. Right, you have the demand for AI, and these are typically driven by the AI projects. For example, maybe you have model developers. As a model developer, you need a lot of GPU, you need a lot of data to build your model. GenAI applications, right? So for example, let's say you want to launch an application like MyShare, right? You need to have a specific model, you need to have a specific compute, and maybe even community participation to improve your application, and finally the end user. Okay, so essentially in this ecosystem, there are 6 players, supply and demand, and the goal of ChainOpera is creating an ecosystem so everybody can start collaborating to build and use the best AI. This is great, right? There is a lot of excitement on that. There is a lot of reasons why decentralization is needed. For example, if we can accomplish it, it's going to be much more affordable compared to using, let's say, compute from hyperscalers. It's going to be much higher quality because data is a bottleneck for better AI, and this way we can access a lot of good quality data towards training and building better AI. It's going to encourage monetization, ownership, right? So you just participate in AI, but you are going to own your data. You are going to maybe, if you are a model builder, have an ownership on your model so that you can benefit from it. Like you go to Hugging Face, you don't have an ownership there. It's going to increase innovation. People can collaborate, right? Not just you have your own company building a model. People can collaborate together and share the model together. And towards the democratization, I think Imad had a great talk. Eventually, it's going to lead to much more democratized AI that we are going to have. Okay, so it's going to be very useful for the society. Now, as you can see, I mean, maybe this year in Token, there is a lot of events on decentralized AI. It's like a hot topic. Everybody is working on that. And that's a project actually we started back about 4 years ago in 2020. Okay, so we have been working on this for several years now. And initial point was when we released FedML, which is a pioneering open source library for federated or decentralized machine learning. Okay, so that was the time that together with Google has TensorFlow federated. We started releasing FedML as an open source project, And by 22, we made it the top ranking open source library on federated learning, surpassing Google's TensorFlow federated, and used by thousands of developers and many companies for doing decentralized AI. Then we said, that's great. It's like we have the compute framework. Let's do it, right? Let's build the economy way before decentralized AI is becoming the trending topic. And we realized actually there is a key technology bottleneck, right? Federated learning is a framework, but you need a technology so that you can build this and create the economy, right? So there is a technology gap to connect supply and demand and make this real, right? So that's what we realized 2 years ago. And let me tell you a little bit what is this technology gap, right? So let's first look at how is it done in Web 2, right? How is it that in Web 2, supply and demand very well connected, and we see $1 trillion economy and AI being created? Okay, so what is the supply and demand in Web 2? Supply is going to be the compute provided by clouds, for example, AWS cloud, Azure cloud, that they are getting GPUs from NVIDIA, from AMD, and providing the compute. So that's the supply. Demand is from the GenAI app companies that are building the best model, the best application, and that's the $1 trillion GenAI economy. Now, how are they connected? There are two layers in the middle between them. Platform layer and the model or application layer. For example, hyperscalers in the past 2 years, they transformed themselves from a GPU cloud to a GenAI cloud by building a platform. For example, AWS has built AWS Bedrock, Google has Vertex AI, Azure has Azure AI. These are the platforms that can run GenAI or AI tasks on a larger scale cloud. Then on top of that, you have the model or app layer. For example, OpenAI has the API for the models. It can also be open source models, so that these applications are running through the platform on the cloud. Now, if you are on the demand side, let's say you are a GenAI app builder, the only way that you interact is through the API for the model or the app to build your application. Right? So for example, use the APIs for using the model, maybe training the model on your data, creating the application, and launching the application. So everything, the connection is API-based. How are they connected to the compute, model layer, app layer? So if you don't have those, you just have a bunch of compute sitting, and the AI community can't use it. That's the challenge, right? So to make this real, right, to cut through the hype, not just saying that we want to create decentralized AI, we essentially need native platform layer and native model and app layer to enable this economy. Right? So for example, we would need an equivalent of Bedrock as a platform running on decentralized cloud, decentralized GPUs, so you can do actual training, actual model inferencing on decentralized cloud, or maybe training across decentralized data. On top of that, we need a native model and app. Right? These should be the models that are built for decentralized cloud, could be trained on a decentralized cloud, and enable users to contribute their knowledge, their data, towards making the model and app better. Once we have these two layers, then you can think about it, the economy is not going to be connecting everybody together. Right? Web 2 economy is bottom up. GPUs are selling to hyperscalers. Hyperscaler to the platform, to the model, finally selling the APIs. Right? But here, we need the whole circle so everybody is benefiting and becoming part of the economy. All right, so that's what we did. Actually, in 22, we said, you cannot do it without these two layers. So we spent 2 years through TensorOpera, which is our Web 2 company, building a platform layer, an app layer that can run on decentralized cloud. And now what we are doing in ChainOpera, we are bringing this technology so that we can create a real decentralized AI economy. So what does it look like? So if you go to ChainOpera, we released that a few days ago, came out of the stealth, is going to have two main components, right? A decentralized platform that you can use for launching or running AI on decentralized cloud, and native AI app ecosystem, so that as a model builder, as an app developer, you can bring your app, let it run on the community, improved by the community, as opposed to just creating your app, let's say, based on OpenAI APIs. So how will it look like? This is the platform, right? So as the platform, you go there, it's similar to, let's say, any other, let's say, Bedrock that you are running on AWS. You get to access a variety of open source, closed source models, right? You can use these models, call the APIs for inference, train them, build agent with them, create application with them, fine tune them, anything you wish, but you can do all of that on community cloud or your own dedicated cloud. Then on the application side, this is a GenAI app. Think about like similar to OpenAI, there is an app store. You can go create applications. These applications would be running on community resources, but they also have the support for community to contribute their data, their knowledge, so that as an app builder, you can improve your model underlying the app. So we started launching the app with 3 representative examples across a variety of modalities. For example, video generation, image generation, or AI agent. But we'll soon open it up for any app builder to bring their app there. And then now you can imagine, you have the model, you have the app layer, so now you can connect both sides of the supply and demand in decentralized AI. You are an app builder, you can bring your app, you can bring your model, train it on decentralized cloud, use the community data, improve it, and have the ownership. You are a GPU owner, you can offer it to be used by the AI community. Or you are a data owner, you can contribute it. So that's the vision, that's how we are building and creating the economy. Now, let me tell you how do we do that, right? So what is maybe some of the underlying technology that enables that? So as I mentioned at the beginning, like as the first step, you cannot claim to do decentralized AI if you cannot even do inferencing on decentralized cloud. Right? That's the first step. You have to run any model and do model inferencing on a decentralized cloud. How can you do that? So that's our technology, Scale LLM. One example, you can look at the paper and look at the technology. So Scale LLM, think about it as a model inferencing framework, right, that is native for decentralized cloud. What does it mean? So it has native infra management, communication optimization, and traffic routing that is optimized for a decentralized cloud, not a centralized, let's say, AWS cloud. It also has end-to-end system optimization so that you don't even lose the performance when you are running, let's say, on community-driven GPUs. Typically, community-driven GPUs are not H100, A100, right? People may have 4090 GPUs. So what we are doing, we are optimizing it so you get the same speed on 4090 GPUs for, let's say, inferencing 13 billion parameter llama, right? On 4090 compared to A100. Now you can compare it, for example, with the enterprise solutions that you have. For example, these are 3 Web2 enterprise model serving APIs you can use by TogetherAI, Deep Infra, Fireworks. First, you would see how does the throughput look like as the number of concurrent requests, right? So if the number of concurrent requests is low, first of all, a Scale LLM competitive matches the performance. But then you see something very interesting. As the concurrent request increases, you see much more advantage from decentralized cloud. Why? Because decentralized cloud is much more scalable. Right? Many of the centralized schemes, they focus on how do I accelerate inference on one GPU. But the power of decentralization is the scale. And that's what you would get, similar to internet, right? Internet is very scalable. You can pass a lot of traffic through that, and that's where you will see not only matching, but the benefit of decentralized cloud. Right? That's something that we haven't seen before. Like everybody wants to say, with decentralized AI, let me at least get what you get centrally. But there is much more gain that you can get. So that's the framework. We even put it in real-world demonstration. Currently, we have run inference on Theta network and soon render network, meaning that there are various models that I mentioned. We run the inferencing on actual decentralized cloud, and then you don't feel even the performance difference, whether it's running on centralized or decentralized. So that's one, let's say, beyond model inferencing, you want to do model training. Right? That's much more difficult, especially as you do model training. You have to worry about communication between the compute tools. Right? You can go to our platform. For example, there is even a zero-code studio. You pick your model, you pick the data that you want to fine-tune, and just do a one-click fine-tuning, or maybe even pre-train. So how do we do that? Our underlying technology there is United LLM. Right? So United LLM is a framework for decentralized or distributed training on decentralized cloud. How do we do it? At a high level, the first thing we do is we want to make sure you can do full model training on one node so that you avoid model parallelism. How would you do it? Through various compression techniques. For example, Galori is a method that you can do low rank on the gradient training, so you can do the full training on one node. Now after that, you need the data parallelism, and that's where federated learning would come. Right? With federated learning, you can do many epochs locally on each node, so the communication doesn't become a bottleneck. Combine the two together, now you can do full training in a decentralized manner without the communication becoming bottleneck. We did that in real world. Right? So we trained our own model, Fox. Fox is a small language model, 1.6 billion parameter, right, competing in the 1 billion to 3 billion range. For example, competing with Google's Gemma 2 billion parameter, or Alibaba QN, or Apple's OpenELM. We trained it from scratch on decentralized cloud. We used Aether's decentralized cloud for that. And again, not only you can do it, you can beat the performance of models built by Google, Apple, Alibaba, right? So it's a real model, like the first example of LLM training on a decentralized cloud, and being able to serve on the decentralized cloud. All right. So you do model inferencing, you do model training. Now you don't want to do much more, right? That's where you would need a platform so you can do any other job. Maybe you want to create an agent, you want to create an application, so on and so forth. And that's where you would need, as a third component, enterprise-grade platform that can run on the decentralized cloud. So what's the technology there, right? So that's where we have a full stack technology. At a high layer, you have the MLOps layer, which is a professional layer that, let's say any AI developer, any data scientist can use for do fine-tuning, agent creation, model training. Middle layer is our own scheduling layer that is built for decentralized cloud. Right? So for example, Ray AnyScale is an example of a scheduling layer running on a centralized cloud. Here we have our own scheduling layer optimized for multi-cloud, decentralized cloud. And the bottom layer is the compute layer. For example, you want to do model inferencing, right? Serving, you can use a scale LLM. That's an example of a framework which is typically open source. Right? So you want to do model training, you can use United LLM. You want to do federated learning, you can use FedML. But you are also welcome to use other open source libraries at the compute layer. It's up to you as a developer what you want to use. So all three layers together, you have a full stack running any other job on decentralized cloud. In fact, running on any cloud. Real world demonstration, Qualcomm is using that platform to offer GenAI services on their GPUs. Right? So Qualcomm is a chip maker. Of course, they make a lot of chips for the phone, but right now AI is hot, so they are making AI 100, which is competing with Grok for model inferencing. They're using our platform, right, as a way to run on their own cloud, which is decentralized. The same manner. All right, so with that, maybe I can start, wrapping up the talk. Hopefully what I convince you is AI economy, right? The only way that we can create it is connecting supply and demand. The way you can visualize ChainOpera is going to be the bridge between AI world, demand, and supply world, which is a lot of resources from the community. Compute, data, verification, or mining. Right? You need to connect the two. If you don't connect them, either you work on the right, you never run on blockchain, or you work on the left, you never reach the AI. Our goal is to change that, make it real by connecting the two. And that's where we also see a lot of potential collaborations, partnership between the Web3 community, because we want to be connecting the two layers together. So if you are a GPU community, talk to us and we can collaborate. We want to create a data community, the same manner. or verification and ZK-ML. Or maybe you are on the right side. You want to build the models that are owned by the community. We can give you the marketplace, we can give you the platform, so such models can be built truly on a decentralized cloud. Or launching an application. Let's say your application is going to be maybe verifying the smart contracts using the AI, right? So you can launch and bring those applications. And finally, on the users, right? The users should be part of the app, contributing their feedback, contributing their data, and helping improving the app. Right? That's where we can connect all of them together. And soon we are also going to have, maybe next week, our airdrop season as a way to start using the credit and using the platform as the way of having the ChainOpera credit as a mechanism and getting the the airdrops for using the system. So with that, let me conclude the talk. I would be happy to take any questions.
Thank you.